Hello, everyone, and thanks for being here, the last session of the day. In my opinion, they have saved the best for last. If you are here, you are not clearly sick of hearing the word agent or agentic yet. No guarantees that you won't be by the end of this session. But I do believe that we have a couple of interesting new innovations to tell you about, and I'm joined by John Abelt here, who is our lead product manager for our Gen AI. If you were in the last session, it was about unleashing agents, and now you're going to step into the future where we have actually unleashed them. We hadn't coordinated, but this just happened to be chronologically this way. But with that, let's get started. Agents unleashed sounds a little bit ominous, right? Because when you're talking about agents, some people think that they are very, very capable, and they're going to be the end of us all, and we are all doomed. Or they think that they are much like my newborn, figuring out how to use basic tools with difficulty, aka a spoon. And if either of these visions are correct, it's not going to be a happy future. But I believe that the reality falls somewhere in between, right? And this talk is going to be about how we're going to actually enable these agents with the current capabilities for any users to actually unleash them and really create them and tap into their capabilities, unlock their potential, and reap the benefits associated with them. So this is going to be the theme of the whole talk, right? But what are these agents that we are talking about, right? Everyone has been mentioning agents, 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 agents. That was 5 agents. All right. So it all started with our beloved LLMs, right? You were given an LLM, and you would give them a query, right? They will produce a response. It will come back to you as a user, or it will get translated to some action that it would get applied to the real world, right? And based on that, the feedback would be generated, and it would be passed to the LLM. You can have a conversation with it, right? The LLM would give you a response that would be wrong a lot of the times, and the only recourse that you would have would be to just manually give it feedback, right? And you would have to do that a lot of times. And this could usually end up in a game of whack-a-mole that is not really pleasant, really, to play around with, right? So that led to some innovations that made this a little bit smarter, right? So it gave them the capability to really critique the attempts that they are producing at answering your questions or producing the action that you are looking for, right? And through that iterations, right, or tap into some model of the world that you might have, right, to kind of like tap into that and iteratively try to improve themselves before they expose a response or an action to you or the real world, right? That meant that you would give them an opportunity to really try and fail, and that would mean that they would succeed now more often and would require less of a feedback from you, right? But we didn't really stop here either, and we gave them some reasoning capability to kind of think a little bit better before they're producing or when they are critiquing or reflecting on what they had done, right? But also give them some memory to remember what they had done, when they had succeeded, when they have failed, right? So that they don't suffer from amnesia every time that you ask them the same question, right? And that meant that we got a little bit closer to really be able to really allow these to run autonomously and get closer to autonomy, right? Now, whenever we talk about agents throughout this talk, we mean basically this kind of a cognitive agent, right? Where we are enabling it with all the things that we have at our disposal to maximize the chances of success, right? And although what I showed is pretty simple, right? It is still pretty powerful. It can do actually a lot of things. And I'm going to give the floor to John to kind of show what we have built with them and what kind of capabilities they actually provide for us now.
Thank you, Sina. So Jim this morning was talking to you about agent orchestration is key from going from questions to answers. We can start with one agent systems, but as the needs of the users or the questions of the users get more complex, even one in the architecture that is showing you isn't always enough. So what do we do at C3 in the product today? The first thing we do is we take an agent that's responsible for breaking down and planning the problem. So it has a memory of how it's planned problems before. It knows about business-specific context, and it's responsible for saying, What do I need to go do, as humans would naturally, break down the problem, create a task list, go solve it. The other aspect that we're providing in the generative AI application is a pre-built set of tools that help the agent address a wide variety of tasks. So it needs to know information about your business, read things from a database. It needs to call different APIs from your enterprise. List goes on and on. So this planning and orchestration agent is then delegating tasks to task or role-specific agents that can better do, the sub-problems that it's broken down to. So we have one for just retrieving information, going across all of your data stores. If you're asking a question about, what's in my orders table in Snowflake, right? It knows how to route that, how to generate the query, how to get the right information. You could also have one for ML insights, which is calling into our ML pipelines that are available in the platform. You can have one specializing in visualization and how to communicate visually to the user, or doing things like optimization using a tool like Gurobi. So what does this look like in action in our product? So, interesting. Drag over.
Okay.
Fun. Should have tried this when we were screen sharing. Perfect. So I started off a question here right before the session about I'm responsible for maintaining some wind turbines. First thing I want to do is understand what I need to look at for the day. So what's the most important turbine that I should be looking at? Let's summarize some of the maintenance actions and parts so I can start planning what this would look like as I dispatch and work with others in my organization. And what you see in these plan boxes is this is the planning agent breaking down our tasks. So it'll retrieve by risk score, so I can see, hey, this is my highest wind turbine with the highest current risk score. Then it will go look, what alerts have I found? What other information can I contextualize about this? So there's an alert related to the generator overheating. And now I can keep going with that context to say, hey, do I have anything that helps me understand how to resolve generator overheating? Well, actually, there's maintenance manuals and documents here. So the next step in its plan is let's go look for that. And as a user, I could go on with these questions, right? There might be other things that I want to know. So are those parts in stock? Could be a good follow-up question. Can I actually go dispatch this to the user? Do I have the right thing? So we get a new plan. Let's go check to see if those parts are available that address overheating. So here's the two that I identified. Gives me some information about what's in stock or not. I could then ask, okay, let's summarize this into a work order and start tomorrow. Maybe I'm happy with how it ends. And what you're noticing here, there's great planning and reasoning capabilities, right? It's actually, it's always understanding the context of what I'm asking these in, giving back relevant information, helping me plan my work. One of our aha moments, and where we'll lead for the rest of this presentation, is I showed 4 questions here. In reality, there might be 50 that you need to go through when you're going through some of these planning actions. And the other aspect that was sort of an aha moment is they likely are the same, right? These organizations want standards and they want best practices that they're giving to all of their users. So how can we take this same planning, reasoning, problem-solving capability, but give it and expand it to all of our users? And this was the theme we'll lead into as Sina goes farther, but it's about basically widening and standardizing those capabilities so that what these can do is growing richer and richer, and also following your organization's best practices for repeatability, auditability, standardization of these different workflows. And then the other thing we'll get into is I could ask a question where it doesn't have a tool or capability here maybe, which we'll talk about as going deep. But how can we let business users kind of grow the capabilities over time, not just use case over use case, but actually what it's able to do by building on these raw underlying capabilities like data retrieval, math, visualization, that are kind of the building blocks for doing a lot of the problem solving we need to do day to day. And with that, we'll pass to Sina to talk about how we're doing some of this widening and deepening.
Thank you so much. All right. As John mentioned, right, we have done a lot of fun things, and within C3, right, we have a lot of pre-built kind of agents and tools that we can tap into. Now imagine that you are a new user, right? You come with your own set of bespoke tools that also is in addition basically to the tools that are available within the platform, right? And you want to now deliver on a specific task. But you know that a workflow or a process that you might have, that you would have liked to have as a tool exposed to you, right, might not exist yet, right? This might be a simple chaining of the tools that you already have at your disposal, right? But you still, if you want to develop that and make it available, what you would have to do is to, talk to your always busy development team, right? Get into a sprint train, kind of try to negotiate with them to kind of like get over their being understaffed and kind of like do the thing that you want them to do, right? And wait a couple of sprints or 6 months until this is done, right? But what we recommend is to instead try our staff agent or a staff suite of agents that we have. What these agents would enable you to do is to create the workflow that you have in mind, that you already have a good view of, right? Which could be based on a process that is already being implemented in your organization or something that you have concocted recently, right? And through natural language and through interaction through natural language, be able to really create these workflows and during that process expands the set of toolings that might be accessible to other people in your organization, right? And also have those basically, new workflows that you have created, right, to the planning orchestration agent as new things that it can use, right, to kind of address your queries, right? So this means that this expands the capability that you are giving this planning orchestration agent and expand the type of queries, type of requests that you are enabling this agent to actually answer for you and deliver for you, right? So this is one way that we can actually really, truly, tap into the full potential of these agents and make sure that actually they are continuously, delivering on the things that you need within, in a timely fashion, right? Another way that we can actually further expand their capabilities is by, deepening the capabilities of some key tooling and agents that they have at their disposal already. What do I mean by that? For example, one of the key agents that we have in our C3 platform is our ML Insight AI agent, right? Although powerful, it can only tap into existing pipelines. And it's very difficult for it to actually create these, pipelines that deliver on different tasks, might be anomaly detection, forecasting, classification. And the reason for it is that to create net new pipelines require a lot of custom work, a lot of manual effort, right, to be able to really make it available, right? So to go around that, what we have done, we have deepened the capabilities that we have at C3, right, in that domain. Specifically, we have worked on our foundation time series models, specifically a foundation embedding model for time series and a foundation model that delivers on multiple tasks. And we have built systems around it that would allow us to now unify and standardize the way that these pipelines are actually developed. So you don't need to do now any manual work, and you can actually tap into these foundation models to really build these pipelines and actually task an agent to do that, right? And also we have actually standardized some systems, or we have built some systems that would allow you to kind of further standardize the way that these models are deployed and insights are truly extracted and communicated to the user from, right? And I'm going to tap into, basically, this would be the two things that I will talk about and go into more details throughout this presentation, right? Without further ado, let's actually start with our staff agent, or what we call automatic agent creation and distillation. So I talked about actually how a staff suite of agents can help you, and we will see how, to actually create these workflows through natural language within reason, right? And kind of relieve a lot of burden off of your very much understaffed development team. But there is another thing actually these staff agents can do. And that is changing the way that we actually really interact and build applications. So you may have access to many different applications that do some key tasks for you, right? But how these applications are developed is that they come with some sort of tooling, some UIs that have envisioned processes that you as a user would want to follow. But not two people in the same organization would want to follow the same process, really, right? So you want some degree of dynamicity. For example, if I have an application that does something very simple, helps you draft good emails, right? And send it to to the people that you need, right? You may actually want to first critique the style of that, right? Refine it. You may want to then critique, the content of it, refine it, and then send it to a set of users that you want to actually send this email to, right? Another person might actually have it in this way, that they may actually want to take advantage of these critiques simultaneously and refine the email that they have, right? Or they may have another type of critique they want to include in this, right? So now, if you want to make these kind of small changes to the way that to the processes that actually is implemented in the application, again, you have to talk to your development team and wait a few months, right? But instead, right, you can actually make use of staff agents to bring that dynamicity that you require from your applications, right? And actually have a staff agent to tap into tooling, the powerful tooling that comes with the applications, to kind of dynamically tailor that application to the kind of work that you want it to do, or the process that you want it to actually implement for you. And that means that this aligns your development team priorities not to really have to address every customer's needs to tailor like small things to their needs, but actually focus on developing essential tools and agents that would allow this kind of innovations like a staff to kind of do the job that they are supposed to do and deliver on the things that like, the users need in a timely fashion, right? Now, staff is enabled by 3 major innovations. And the reason that I mention that is that each of these innovations, they're guaranteed to improve over time, right? And we have designed the staff and the agents associated with it to directly be able to tap into the improvements that each of these innovations that you see there directly. So the staff that you will see, hopefully now, it's the worst staff that you will see, and it's guaranteed to improve over time. So that means that you can actually recognize the value of your development team and have them focus on the right things, and instead of using the development staff continuously, right, for a lot of the things that you might be able to do yourself, just use the other staff instead. Right, so what is a staff? So staff stands for a specification to tiny agent fine-tuning framework. Mouthful. So how does it work? So a user might actually come. We know who they are. We have some information about their organizational metadata, who they are, what roles and permissions they have, what data they have access to, what tools they have at their disposal, right? And given a description that they may have in natural language and a template that we have actually that define actually a workflow, we actually use our workflow generation agent to actually create that workflow structure that they are looking for. Now, through natural language, they can interact with that agent and have it define actually how it looks like. For example, if this is one of the workflow that actually the agent actually is creating, I can actually tell it, look, I want to mix things up a little bit, right? I actually want to combine the refiners and have the actually critiques from both of them, right? Or I can say that, I have an extra step that I want to actually add, and it's going to add it for me. And I can, through this process, I can audit, approve every step as the agent is going through and give it feedback until I'm happy with a specific workflow, structurally speaking. Now, after that, things get into gear. So the first thing that we do is that we recognize that you may actually note that actually there are cycles in this graph, unlike other agentic workflows or workflows that you would see before. So the first thing that we do actually is that we decompose this. We do this for 2 reasons. One is that we can actually tap into our coding agent to expand the capabilities of that you have at your disposal or your organization have at disposal, because this may actually correspond to agents that other people might want to use and you would want to standardize over. And it will actually make the code generation for the overall workflow also more reliable, more robust, and more performant. So that means that the overall actually coding will actually be easier. And this actually also adheres to the best practices for development, right? So you are doing modular code development. You can create tests for that based on the interaction that the user have actually in natural language with the agent, right? And you can actually commit that code and make it accessible to all of your users in the organization. At this point, you can also, of course, continuously improve it through natural language again, talking to the agent, right? At this point, if you are happy and your iterations have actually bear fruit, what you can do, you can just go and deploy this, and you can actually tap into all the platform capabilities that we have that will allow you to manage and deploy and monitor basically these multi-agent workflows, right? And make it readily available to your orchestrator or planning agents. Now, if this doesn't satisfy your requirements, that might be due to cost, that might be due to latency, that might be due to the fact that you need to work in an air-gap environment, right? And that prevents you from actually using the OpenAI offerings, Anthropic offerings, or what have you. We also have a recipe that would distill this basically into a smaller LLM. Now, why can't we use that smaller LLM already? And the reason for it is that for a multi-agent workflow to work, an LLM needs to be able to create answer and actually critique those answers, right? And specifically, it needs to be able to create good answers and provide good critiques in such a way that actually it can pick up on those critiques and actually fix itself, right? And small language models fail within that. So we have actually developed a distillation recipe that has 3 specific parts. That is, it has a specific data set generation framework, and it can then iteratively, through what is called in the industry direct preference optimization, or DPO, continuously improve itself. And actually then we can distill that framework into a smaller LLM that they can use to replace the bigger LLM in your framework or to take over that framework altogether. Now, having done that, the third component kicks into gear. That is our decoding frameworks that further make sure that we are actually really extracting the full potential out of these smaller LLMs as much as possible. So we are actually expanding training compute to distill these smaller LLMs, and also we are expanding compute at inference time to kind of make sure that this smaller agent really delivers on the task that you are looking for within the specific process that you have in mind. So this actually, we have seen actually great performance improvements here. So I'm just going to quickly talk about actually this graph. So Mistral 7B is a small and very weak model. And it is the reasoning task benchmark that if you actually ask the model to answer a query from that benchmark, it succeeds in 45% of the cases. And if you now say, OK, critique your answer and then fix it, right, it will improve it like 1.2%. If you could use GPT-4o in this loop, right, which you can't if you are in this route, you get 24% improvement. And if you now distill Mistral 7B with our distillation process, you can actually narrow that gap quite significantly and actually get to the performance that you need that would happily persuade you to use this, a smaller LLM instead of the GPT-4o in your workflow. So this means that we can now complete the staff with our distillation process. And once we are done, we can then deploy that based on the, a smaller LLM or agent based on a smaller LLM. Now, we have worked very hard on this, and this is graduating and hopefully coming soon to a version of the product near you, and I will leave to John to kind of show you how that would look like.
So if we think back to what I was doing in our search interface, where I was asking about what's the most important thing to focus on, what are the maintenance actions, what parts do I need? The way we're reimagining this now is you'll still have that search interface. It's really excellent for solving a lot of the problems that come to users. But you can also come and now create a workflow. So this is giving it a name, description, and a task. And then for building this, it's similar to what you would do through the search UI, where you're describing your requirements. It could be a big, long list like I gave it, or it could be more conversational. You're like, hey, I do step 1, then I do step 2, then I do step 3. And while it's going through this, every time you update the requirements or give it new tasks that it should be doing every time, it's updating that workflow definition. So it's going through all the processes that Sina was showing you to give you the readable to the end user version of here's how I'm breaking down the task. Here's how I'm segmenting your task into agents. Here's the tools that it can use during each step in the process. And then as a user running this, instead of going through and asking every single list of questions that I have, we can now automate this. So it'll run through all of the steps that I've described. And really, if you think about what you're getting here is it's a dynamic UI that you've personalized to your workflow, right? If I always want to do these 50 steps, I can say every time an alert happens in this case, go run through this full process. Go give me that full output of results so I can click on it, see it the moment I get in, and I don't need to go through some of the process of breaking it down step by step. So we think this is really transformative, again, in how we think about applications, right? Giving you the personalization while also making it standardized. So every time you open it, it's going to do the same thing, right? And then as a last step, you can also go and distill this. So this leads into what Sina was saying, where you may want to use a small language model to actually run this. So for any of the workflows, you can kick off a distillation process where it'll generate the data set to test this. and then start the training and distillation process. And when you come back, you'll have a small agent that's running your entire workflow.
Yeah. You may want to get 1 or 10 coffees before that is done, because it's still training an LLM. So it will take a little bit of time. But by the end of it, hopefully you will be happy with the results. All right, that was a great segue. So now let's talk about the other way that actually we can enable these agents, right? And this is an area that I'm very excited about, and that is basically the work that we have done in foundation time series modeling. So before I actually dig deeper in actually why we started to target this problem, let's actually walk through an example that might be far too real for a lot of you in this room. Let's assume that I have a fleet of 1,000 pumps, right? They all pumps, they do the same function. They may be coming from different vendors, they may have different set of sensors, right? So how would I do it now? The way that I would actually start with is that I would start with one of these assets, right? I would do my model development, basically do my feature engineering, for example, develop a task model on it. I have some evaluation rubric that I have, and I iteratively improve this model and have it ready. Once I am done with that, I can then deploy it. I may have some interpretability module that I put on top of it to kind of like make these predictions that the model is actually producing more understandable by an end user. And I will build some decision-making, rubrics around the predictions and interpretability results that come out of the model, right? That's great. Now you have done it for one model, do it 1,000 more times. So now you have to do it for every pump, which means that all of this manual process that you have to go through needs to be repeated. There is really no direct way of transferring knowledge from one asset development to the other, right? And, there is really, if you have an asset that you really want to have these pipelines running for it, but you don't have any data for it, that's out of the question. You just have to wait, right? Now, even if you are happy with this, which I don't think you would be, especially the time frames that we usually function under, once you deploy this, the way that insights are generated or provided to the end users, they're still not really, they're still very finicky, and they are still not in the form that is like directly usable by an end user. Wouldn't it be nice if you were in this situation that you were working with some, asset like a coupled rotational system, right? And you observe that, okay, something's off here, right? This could also be a patient if you're a doctor, right? So now, wouldn't it be nice if you could just go and ask in natural language, what is happening here, right? Should I be concerned? Is there something wrong here? And you get back answer in natural language, tapping into not only the manuals that you might have, but actually also in similar events that might have happened in the past, similar patients, or similar things that might happen to the same patient, right? To come up in a natural language and telling you actually what has happened. If this is something that is interesting to you, then you want to probably wake up and actually listen to the rest of this presentation. But before I talk about actually how we actually are going to have our cake and eat it too, let me actually make things a little bit more structured. So the way that we currently develop models, we start from data cleaning and preparation. That's never going to go away, right? And we have 3 main ways of actually developing these models. So one way is that we do feature engineering, and we develop a task model on top of it, and we have our evaluation rubric. The other way is, and if you want to do that, the needs that we have for data, or annotated data specifically, is medium. The compute would be low because the task models are usually simple and the feature definitions are simple. Interpretability would be, the interpretability complexity would be low, especially if you have done a good job at feature engineering. Manual effort would be very high, specifically because you have to do that manual feature engineering, and the complexity of the overall pipeline is low. You can also just use a neural network, right, and just make it all black box. That would mean that a lot of the things that were like manageable becomes high, right, including interpretability specifically. It's just a black box. You don't know what's happening in there. And it's a bigger model, so it's more complicated to actually deploy and maintain. And there is another way that breaks this down into 2 parts, where you, in an unsupervised way, from your data, learn some representation of your data, right? And that becomes your automatic feature creator, right? And then you will have a task model built on top of it. And while it makes things slightly better, still it suffers from a lot of things, right? And now on top of that, you have to have an iterative loop here, right? Which really, although the first row seems very appealing, it's going to make it very difficult actually to do things. Furthermore, the models that are developed using these three frameworks, usually the performance that you observe from them, overall performance in detecting anomalies or doing different things, usually improves as you go further down this path. So wouldn't it be nice if the last one was the best one that we could do? Now, even if you develop this and you're done with actually this development, you have to now deploy it, right? That means that you have to manually design some interpretability technique that is usually done post hoc, right? That takes information about the predictions from the model and the structure of these pipelines that you have and translate it into things that then you can consume in decision-making rules, right? Or rules that allow you to kind of like do things on top of this, right? That again have been manually created, right? So it's still a lot of manual effort that is required also to deploy these kind of pipelines that you have designed. All right. What we think is to address all of these issues and make things just easier to do is to do foundation models for time series. Our vision for it has two stages. The stage one is that we actually develop a foundation embedding model for time series, and stage two is that we actually develop a multitask time series model that sits on top of this embedding model. So how have we done this? It's not an easy task actually to develop a foundation model for time series. It's because you are mixing data from very different domains. You may have wide variety of sensors, different numbers of them, right, for each of these data sets, right? They may belong to widely different domains. So what we have done is that we have taken inspiration of how SMEs would work, right? If I show a set of time series to an SME and just don't tell them what it is, they'll be like, okay, what is this? Are you kidding me? But if I tell them what each of these sensors are, they can tell you a lot of things. They can tell you, oh, this is a pump. This is a pump from GE. This is a pump that is actually working like this, and this is a pump that is actually suffering from this issue, right? So we provide the same information for these embedding models. So we provide them with this textual information that is telling it, what am I actually giving you to reason on, right? This allows us to do multiple things. This allows us to walk the narrow trade-off between enabling this model to learn across data sets, but not to collapse fully because all these data sets are from very different domains, right? And this allows us to, again, have an embedding model that truly taps into the information that might be hidden across all of these data sets. Once we have done that, we also have developed a multitask time series model that sits on top of this, that simultaneously learns across different tasks that are common in time series modeling. So that means that not only we are learning across data sets, assets, domains, but we are also learning across tasks. So these actually models gives us very rich information, very rich representations of the data that we have that would allow us to do a lot of fun things. Specifically, if we go back to the model development process that we had before, and our good old way of doing it, it will transform it in this way, where you will have now a frozen embedding model that translates your data into some feature set, right? This embedding model, it's only one of them that you need, right? Not 1,000 of them if you have 1,000 pumps. And the task model that you have here is not 1,000 task models that you need. It's just one task model that you need, right? So that means that you can develop only one pipeline versus 1,000, and you can tap into the data that you have across all of your assets with just one pipeline, right? So that means that the data needs to become low because that embedding model is now frozen and outside, and you're actually pulling all of your data already for all your assets. Your data poor assets, they won't be alone and sad, sitting in isolation. You will actually have a model that will be able to deliver insights for them out of the box. The compute would be low because, again, the task model that you will still have would be a simple one. And even the interpretability complexity would be low, and I'm going to tell you actually why that is the case. The reason that is that this embedding model that we have also will fundamentally change the way that we deploy these solutions and deliver even further insights from them. Specifically, all the orange boxes are now gone, so no manual effort is required. And we have now a new module that we call Retrieval Augmented Interpretability that actually would allow you to, knowing the embedding model and representations, would actually allow you to really do the thing that we actually dreamed about in the beginning of this part of the talk. What is Retrieval Augmented Interpretability? Assuming that now you have your time series data and you know about the descriptions, you can partition these, and now you can actually draw commonalities between these frameworks and your retrieval augmented generation, if you know what that is. So this could be your document that you are chunking, but now this is your time series, right? And you can pass it to your embedding model, and you can keep a time series, a vector store for your time series that can talk to, another vector store that might have more informative, information about the time series, annotations, for example, associated to this time series. Or it could be that you have periods of time that you have a lot more information about them, a lot better shift notes, or more detailed information about that. And when a new time point comes in, that allows you to retrieve similar time points that have happened in the past, right? That might be across the same asset or across the fleet of your assets, right? And that would help you to also extract all the annotations that is associated with them, all the shift notes, everything that you actually had created over the years that actually these assets have been, this fleet of assets has been in action. And then you can also use the task case that we discussed to verbalize the situation based on what your actually models are predicting. And then you can tap into other bespoke agents that, for example, goes and searching your manuals based on the question that is at hand. Or if it's now a demand forecasting case, may actually go and do a web search to understand what were the micro and macroeconomic situation at the point that were similar to the current thing that I'm seeing. And then it's going to give it to our LLM, and it's going to give you a response, right? So, and very rudimentary implementation of it would look something like this, that you have your questions, you're invoking our AI, and what it's going to do is that it's going to retrieve similar time points. And if there are some shift notes associated to the event that you're observing, right, it may actually grab those and actually have it pass to the language model to actually summarize, reason around, and actually provide an answer for you. And this is how it would look like. So for example, if I ask to retrieve top 10 events that have happened in the past, it's going to come back to me and say that, yeah, based on the things that I'm retrieving, I see a couple of events that are similar to this, right? Should you be concerned? Yes. This is how you would fix it. This is how you would actually fix it if the issue is associated to one of the type of events that I have actually extracted, or if this is associated to the other one, and actually goes even further, compares the shift notes associated to these, and tells you actually how you can distinguish between these, right? Which is actually very nice and unsolicited. So this is actually something nice to see that the LLMs can actually help us with. Now, you can do even further. You can actually build other type of systems on top of these now foundation models. Specifically, you can actually completely change the way that you extract information from your SMEs and you actually interact with them in production. Specifically, let's go through the same time series. Let's say you have historical time series data that you have chunked, right? Now, you may have access to a small annotated set of time series data, right? It might not be big, right? But it's something to start with. Now you can actually start processing this data and see if the current time point that you're looking at can be associated beyond a reasonable doubt to one of these, annotated time points or time periods that you have, right? And if that's the case, you say, okay, I'm fine. You continue on. If it's not, then you basically include your SME that would help you to annotate that actually time point and actually add to the knowledge that actually you have that you can use actually in production. That means that by the end of this process, you will have a non-parametric expert companion that releases your expert from all these emails and messages that they are receiving that is distracting them from the thing that actually they can do effectively with their time. Now, the kind of embedding model that I showed you actually these results from is actually one of the early checkpoints that we have actually developing, and based on like a combination of very different data sets, right, that are available open source. Now, we have trained this model, and this is the type of embeddings that it's actually producing. So let me tell you actually what you are seeing here. So we are mixing a lot of different data sets from very different domains, right? Now, Each column and row in this matrix is associated to one of these data points, right? And we are calculating the representation associated to each of those data points, and we are comparing them to one another. So if they are very similar to one another, you will see a very dark colored element in this matrix, if you will. And if it's lighter, that means that they are less similar. It's block diagonal. That means that I've been able to distinguish between all these different data sets, which is nice, but big whoop, right? But if I actually double-click on it, and remember that this has been trained in a fully unsupervised way, it actually has learned representations of your data that allows you to distinguish between things that are hidden in your data. For example, one of these data sets that we are using is called basic motion, where we have attached accelerometers to people. They're just doing different things, right? And it's about actually distinguishing between what activity they are doing based on these time series measurements associated to these accelerometers. And we can see that actually we have been able to distinguish between them, right, without even telling the model about these annotations, right? So the representations that this model is actually producing is highly, highly informative, right? And another proof of the pudding is that if we use this model, it's actually beating a lot of the benchmarks that are associated to this domain by a pretty large margin, especially if you look at the forecasting benchmarks. It's actually beating them by almost a factor of 100%. So basically, this is the way that we are evaluating how rich these representations are based on how well I can train a task model on top of them, right? So now, I hope I actually conveyed the message actually of what can be done by these technologies that I told you about. We have talked about how we have actually enabled anyone to expand the capabilities of agentic systems and tap into their capabilities by just really allowing them to go wide and actually spread their wings. And also how we have picked some key domains and some key toolings that would allow the tools that we have to become better, more reliable, easier to interact with, specifically by agents, to actually allow them to then go even further. And we are prepared for the future that actually this kind of technologies actually provide for us. So if anyone can now create a workflow, create a multi-agent workflow, there will be a lot of them. So you got to be ready for it from a platform perspective to manage them, monitor them, and allow different people to discover, and the agents to discover what tooling they have at their disposal and what tooling they are allowed to use. So last year, actually, I talked to you about some of these things that actually I discussed now. Then it was just a one-liner that I actually put at the final slide of my presentation. But we have been hard at work, and we have delivered on some of them, all of them. And to just give you another one-liner for next year is that we talked about actually how we have agents that would enable you access to your data, that would enable you to create and access deeper insights that can be built on top of them. Now, what we're going to work on next is to equip this tooling to really optimize decision-making based on this data that they are retrieving and based on the insights that they're actually delivering to us. So stay tuned for that. A lot of the things that I actually talked about, we will be publishing blogs about them. So please keep an eye out for those. But if you are impatient and you want to learn more, you want to try them, you want to be partners and be better users of this, come and find John and I. We would be happy to talk more about this until you tell us to stop. Thank you very much. Any questions?
I've been working with Con Edison for the last few years with your guys' platform. And really that, once I started working there, and we built about 18 use cases for them in the last year and a half, 2 years. And right off the bat, I discovered that everybody who really wants to use all of this is doing a lot of math, and that the thing I end up spending most of our time with is either writing algorithms or, and this is probably more important, talking to all those engineers who are using your tools, and then it's this feedback loop, where we're just going back and forth. So first I want to say, this is awesome. High five from across the room. This is really exciting to see what you guys are doing. My big question when I'm watching you guys talk about this is, when can I have access to be able to use one of these agents with some more advanced things? Like, I want this thing to do some stuff with that these engineers would want to do. And like, how do I plug this into like a custom application for like Con Edison? Because I'm thinking of 20 different things that I know that they would be really excited to do with it.
Yeah.
So the live demo I gave you that's our current GA software. When I was getting into the workflow description, we're already starting to work on that. Best estimate is probably this summer.
Okay.
Yeah.
And are we going to be able to get access to this in the way we would some of your other tools, where we can, like, from code, we can access some of these things and fire them off, or get them to fire things off in our code? Maybe we've got some really hard math.
Yeah, so our agent architecture lets you take action. So actually, I maybe showed that at the end, but I actually called a create work order. I said, hey, create this work order. And what it's doing is actually calling an action to go submit the work order through the API that we've set up. So it's up to you as you're defining agents, which capabilities you want to give it. But if you want to give it the ability to take actions, it certainly can.
I have one last question, and that is, a ton of the time that gets spent for us is pre-computing data, because it's huge, it's massive. Millions of customers for Con Edison, right? So you can't just do that live, obviously. So we have applications, but we've got to go do an entire phase of the application's business logic over the weekend, every weekend, for hours and hours. So are we going to be able to plug this into jobs that would run? Like, those actions, would they include jobs so they can just fire it off?
Absolutely.
And anything in the C3 platform ecosystem can be plugged into this.
You're going to make them so happy.
Whether you want to becomes a design decision.
I wondered about the control, and you said how many people are going to start using it. So
yeah,
that's good.
Any more questions? Yeah.
One more.
First of all, thank you so much, Sina and John, right?
Yeah.
It's always very interesting to see your reference of the movies here, for example. One question I have is, I think the idea of the time series foundation model is brilliant. So you basically train the model to speak the language of the time series, and then you predict it. But I think I can see it being used by, for example, a lot of the assets in oil and gas, because that's where I assume you train your model, like majority data, you're training your model, right? So they speak the language of a turbine.
Yep.
But now, say that I want to use this model to predict a bioreactor in pharma. Would that work? Where basically, I think, because it's similar, like you train the model all in English, then it's very good at speaking English, but if you didn't have any data point in Japanese, for example, it probably doesn't speak that way.
That is absolutely correct. So we have used actually, so the initial version that I am showing here, we have used actually a very diverse set of data sets. Actually, it has data sets from EEG measurements to really machinery fault, internal combustion engine, or what have you, right? And we did that actually to kind of make sure that what we hypothesized actually that this actually can learn across very diverse set of tasks, whether it can or not. Now, you're absolutely right. There is actually a lot of parallels between this embedding model and an embedding model for natural language, BERT, right? If it's something is very much out of domain, it's not going to work so well. But we have all the necessary tooling and APIs that will allow anyone to fine-tune this further, right? To do continued pre-training or post-training, and I can tell you what I mean by these in this context later, to kind of like make it really adaptable to the kind of data that they are seeing, right? And it's highly, highly recommended to do that. We actually have a longer run of this actually that is running on a bigger model with a bigger data set, because there is still a lot of data sets that are out there that we didn't include. And for time series, actually synthetic data is a very much viable path to also work with that we are actually tapping into. And when I say big, by the way, don't be afraid. This is, when I say big embedding model, I'm talking about from a standard of early 2000s. I'm not talking about LLM size, right? So these are like a few million parameter models versus a few billion parameter models. And you can do a lot of things still with them. So to answer your question, you're absolutely right. Hopefully the newer model will have expanded capabilities. But if you have data, you should fine-tune these models on your data so they actually have that in their context. And who knows, maybe actually there is something actually in the original model that you can actually even leverage. Or you can even train it from scratch. So again, they are not as complicated to train as LLMs. I know there has been a lot of work that people have tried to reuse LLMs to do these things, but it's, I think, lazy work there, and I don't think they are as efficient as they can be. But yeah, all of that capabilities exist to kind of make sure that your data is in domain, and you can tap into all the fun things that I actually showed.
Thank you so much. I'll ask more follow-up questions during dinner. For example, is that open source or not?
Absolutely. Any more questions?
Thank you all.
Thank you all. Come and find us and talk to us.
Yeah, come talk to us.
Cheers.